Welcome to episode 42 of 100 Days of Data. I'm Jonas, an AI professor, here to explore the foundations of data in AI with you.
And I'm Amy, an AI consultant, excited to bring these concepts to life with stories and practical insights. Glad you're joining us.
Ever wondered how complex objects like lists, numbers, and strings are transported seamlessly across apps and systems? Today, we're diving into JSON.stringify, the unsung hero behind data exchange.
That's right. JSON.stringify is like the magic translator, turning complex data into a shareable language. Trust me, once you get this, you'll see data moving in your company like never before.
Let's start with the basics. JSON stands for JavaScript Object Notation. It's a lightweight, text-based format used for structuring data. JSON.stringify is a function in JavaScript that converts objects or values into a JSON string.
So essentially, it takes your data objects, the ones your app or system uses, and turns them into a string format that can be easily sent over the internet or stored.
Exactly. Think of it like packing a suitcase. Your suitcase is the JSON string, neatly packed with all your essentials, the data. Before you send it off on a trip, you can't just hand over a pile of clothes. You need an organized way to transport it.
That's a great analogy. In one project I worked on with a retail client, they had real-time inventory data scattered across different platforms. By using JSON.stringify, they could package the inventory info and send it to various systems reliably, like a well-packed suitcase going from store to warehouse.
Diving a bit deeper, JSON.stringify handles different data types, numbers, strings, booleans, arrays, and objects, but it only includes serializable values. That means functions, undefined, or certain special objects are omitted or altered.
Which sometimes trips people up in real-world scenarios. I remember a healthcare startup trying to send patient data, including some complex object methods. JSON.stringify stripped out the functions, causing errors downstream. We had to refactor their data models to separate data from behavior.
Yes, understanding those limitations is critical. The output of JSON.stringify is always a string that represents the entire object structure in a readable text format. This makes it ideal for APIs, configuration files, or logging.
And it's not just tech teams who use it. For finance firms, JSON.stringify plays a key role in transmitting transaction records between services. One bank I consulted with had microservices communicating purchase data using JSON strings, smoothly serialized with this method.
Another useful feature is the optional replacer argument in JSON.stringify. It allows you to control which properties get included or can modify values during serialization.
That's super handy. For example, in automotive telematics, you might want to send only certain vehicle sensor data, excluding irrelevant or sensitive info. Using the replacer, you can filter the data live during stringification.
There's also a space argument that formats the JSON string with indentation and spacing, making it human readable.
That might seem small, but in practice, when teams audit data logs or APIs, clear formatting saves tons of time. I've seen debugging sessions drag on until someone formatted the JSON output properly.
Now, it's important to note that JSON.stringify can throw errors when dealing with circular references, objects that reference themselves directly or indirectly.
From consulting experience, circular references cause serialization nightmares. Imagine a customer record including a list of orders, and each order links back to the customer. Straight JSON.stringify won't work.
To handle such cases, developers either customize the replacer function to break the cycle or use specialized libraries designed for deep cloning or serialization with circular references.
I've helped several clients adopt such libraries. For example, in healthcare data exchanges, patient records often have interlinked references. Careful serialization avoids system crashes.
Importantly, JSON.stringify is part of a pair, the companion JSON.parse, which converts JSON strings back into objects. Together, they form the backbone of data interchange in modern applications.
Right. The stringification and parsing cycle are everywhere, from loading web pages with dynamic content to mobile apps syncing data.
Let's briefly consider security. Since JSON.stringify outputs plain text, it can expose sensitive info if handled carefully.
That's true. I've seen cases where accidentally stringifying entire data objects exposed passwords or personal information in logs. Teams need strict data governance when using Stringify.
So, to summarize the core principle, JSON.stringify turns data into a textual snapshot, very efficient for moving data between systems or saving it.
And the business impact? Faster integrations, clearer communication between services, and smoother, scalable data workflows.
Amy, can you share a quick example that brings this home?
Certainly. At a recent retail project, the client's ERP, their website, and warehouse scanners all spoke different languages. Using JSON.stringify and JSON.parse, we standardized their data pipeline. Inventory updates from the website were stringified and pushed to the warehouse in near real time. This cut stock errors by 30% and sped up order fulfillment.
That's a perfect illustration of theory meeting practice.
Also, it's worth mentioning that JSON.stringify originated in JavaScript, but many programming languages support JSON serialization now, ensuring broad compatibility.
Exactly. JSON is the lingua franca of data exchange. JSON.stringify is one of the first tools you learn when working with APIs or networked applications.
So for anyone wanting to lead AI initiatives or data-driven projects, grasping how data gets packaged and transmitted is essential, and JSON.stringify is a simple, powerful starting point.
Let's end with a key takeaway.
JSON.stringify converts complex data into a JSON-formatted string, making it easy to share and store data across systems.
And understanding its role and limitations helps you design better data flows and avoid common pitfalls like missing properties or circular references.
And next time, we'll explore how data labeling underpins machine learning and why quality tags make all the difference.
If you're enjoying this, please like or rate us 5 stars in your podcast app. Leave us comments or questions. They might just show up in future episodes.
Until next time, stay curious, stay data-driven.